unit circle pops up continuously throughout Calc 2, so it's always worthwhile to do a unit circle review before we get started. So let's look at the circle that I've drawn here, and you can see that a unit circle has a radius of 1, and it's centered at 0, 0. So the unit circle, grab another color here, unit circle. Characteristics is that the radius is equal to 1 and it's centered at 0, 0, the origin. A positive angle, right, recall that a positive angle is a counterclockwise movement from the positive x-axis. So positive angle theta is a counterclockwise from the positive x-axis. So in other words, if I am going, right, counterclockwise, that theta would be a positive angle. A negative angle is going to be an angle that's created by a clockwise movement from the positive x-axis. So we're going to go clockwise. And I know most of this should be a review, but it always is helpful to get a good review of the unit circle and the trig functions before we get started and where they came from. So let's talk a little bit more about the trig functions now. I'm going to grab another color for you. And I think everyone remembers the little jingle, SOHCAHTOA. Or there may be something else that you learned. Sorry about that. I'm going to mute my laptop. So the sine of the angle theta that's drawn on the unit circle is defined by the opposite side over the hypotenuse, which in terms of the graph that I've drawn, let me scroll down here, is simply y over r. Right, if you're looking through here, right, the opposite side is that y and the hypotenuse is the r. And the cosine of theta is equal to the adjacent side over the hypotenuse. Or in terms of what I've drawn, that's just x over r. And then, of course, tangent of theta is equal to the opposite over the adjacent, which is equal to y over x. And if you notice on the unit circle, since r is equal to 1, the x and y coordinate is simply cosine theta, comma sine theta. So if that's the case, and that's true for any ordered pair, in the first quadrant. So given that any ordered pair is simply cosine theta, sine theta for any point in the first quadrant, that would mean that your tangent of theta is simply equal to sine of theta over cosine of theta, which is a trig identity that most of you should remember. So let's talk a little bit now about the radian measure. So we know that 2 pi radians is equal to 360 degrees. And we use these equivalencies for conversions all the time. So pi radians, if you just divide both sides by 2, is equal to 180 degrees. So 1 degree is equal to pi over 180 radians. And 1 radian is equal to 360 degrees, right, divided by 2 pi, which is equal to 180 over pi degrees. So that is how we get the conversion units, how we convert from one unit to another. Let's talk a little bit about that circle again when we're looking at it. I'll just draw it quickly. And it's not the greatest drawing, but you get the idea. Try and at least join this a little bit better. If this is some angle theta, and now we know that this is r, right? Then an arc is going to subtends, that arc subtends angle theta. Right, so this is your arc that is subtending the angle theta. And we know that 1 revolution around the circle is 2 pi radians. So if the arc is exactly the length of the radius, so if the arc is exactly, right, that arc that's subtended by the angle theta is exactly the length of the radius, the radius r, then the angle theta is 1 radian in measure. So that's going to end this first video. And the next video, we're going to look at where the numbers come from on the unit circle. For instance, where does the square root of 3 over 2, the point square root of 3 over 2, comma 1/2 actually come from? And we'll look at that in our next video.